Hello, welcome to solving some interesting integral questions. Okay, so in this video I'll take you through how to solve an integral question like this. Okay, if you've not subscribed to my channel yet, kindly subscribe for more videos. Alright, let's start. So if I have integral like this, how do you go about it? Okay, so here you use an interesting substitution called the half angle substitution. Okay, so you set t be equal to tan of x over 2. Okay, now with this, you know that the t will actually be equal to half, or the t dx, let me call it that way, sec squared of what, x over 2. And now with this, we get something like dx is equal to 2 the t, okay, I'm making the x the subject here, then over sec squared of what, x over 2. Alright, okay, so now with this, how do we go about it? Okay, let's try to simplify this and guess. We want to get an expression for cos x. Okay, now mind you that from this whole t equals tan of x over 2, I know that t squared is actually equal to tan squared of x over 2. But from a trigonometric identity that we know that 1 plus tan squared of x over 2 is equal to a sec squared of x over 2. Okay, now with that tan squared of x over 2 is what, t squared, so we have 1 plus t squared is equal to sec squared of what, x over 2. Alright, so it means sec x over 2 is actually equal to a square root of 1 plus t squared. Okay, now this means sec is what, 1 over cos. Okay, so it means that cos x over 2 will actually give us what, 1 over square root of 1 plus t squared. Okay, so let's keep this is what we need, and the sec squared of x over 2. Okay, so we come to the dx, we place sec squared of x over 2 by what we've got in here. Okay, we've got in t 1 plus t squared equals sec squared of x over 2. Okay, so now let's come. We know that tan of x over 2 is actually equal to sine of x over 2 over cos of x over 2. Okay, now this means that tan of x over 2 is t, and it's equal to, or times, let's say so this times cos of x over 2, and cos of x over 2 is what, okay, cos of x over 2 is actually, so let me put it there, x over 2 is equal to sine of x over 2. Okay, this means that t over square root of 1 plus t squared is actually equal to a sine of x over 2. Okay, now this will help us get cos s. So sine of x over 2 is also t over square root of 1 plus t squared. Okay, so now we know that from a trig identity, cos 2 theta is equal to cos squared theta minus sine squared what, sine squared theta. This is a trig identity. Okay, so it means cos of 2 times x over 2 means cos of 2 times that, it should be cos squared of x over 2 minus sine squared of x over 2. Okay, now this will give us a cos x, because 2 times half will give us 1, so 1 times x will be cos s. It's equal to cos squared x over 2 is this, so I square it and I get what, 1 over square root of 1 plus t squared, then minus, sorry, when I square it, the square root will go. Okay, so cos squared x over 2 will give me 1 over 1 plus t squared, because is what, 1 over square root of 1 plus t squared. Okay, and when I square it, I'll get that 1, then minus t squared over 1 plus t squared, and this will give me 1 minus t squared over 1 plus t squared. Okay, that is cos x. Okay, So now we know our dx in terms of t, we know our cos s in terms of t. So now let's come back and put it in this whole integral, okay? So now with this, the whole of this integral will be something like dx is what? 2 dt, okay, over 1 plus t squared. Then the whole of this divided by 5 plus 3 times 1 minus t squared over 1 plus t squared, okay? And the whole of this will give us something like integral of 2 dt all over 1 plus t squared divided by 5 plus 3 minus 3t squared over 1 plus t squared, okay? And this will be integral of 2 dt over 1 plus t squared, then divided by 5 into 1 plus t squared plus 3 minus 3t squared all over 1 plus t squared, okay? Now this will give me 2 dt over 1 plus t squared divided by 5 plus 5t squared plus 3 minus 3t squared, okay, all over 1 plus t squared, okay? So this is what we have to simplify. So this is equal to integral of 2 dt over t squared plus 1, then you reciprocate this times t squared plus 1 over, when you simplify the numerator, you get 8 plus 2t squared, okay? Now this will be equal to, the whole of this will take this out, so we'll have integral of 2 over 8 plus 2t squared dt, okay? Now this will be the same as integral of 2 over 2 out 4 plus t squared dt, okay? So this will take this out. Now I get integral of 1 over t squared plus 4 dt. So now we've gotten something which is very simpler to solve, okay? And this will use what we call the normal trig substitution, okay? Alright, so let's do that first. So now we have this to solve, 1 over t squared plus 4, okay? If you remember, we said you can factor your 4 out, and this becomes t squared over 4 plus 1, okay? And this will be the same as 4 into t over 2 all squared plus 1, okay? From our normal trig substitution. So this is equal to integral of 1 over 4 out, then t squared over 2, sorry, t over 2 all squared rather, okay? This is t over 2 all squared, t over 2 all squared plus 1, okay, then dt. Alright, there was a dt here. So now we let what t over 2 be equal to some tan theta, okay? Then t will be equal to, this is a different t, please, it's different from this one, okay? T will be equal to 2 tan theta, okay? Now the t is equal to 2 sec square theta d theta, okay? That will be it. So now this will be equal to integral of 1 over 4. Now if t over 2 is tan theta, then t over 2, if I put tan theta in place of this side, okay, I'll get tan theta all squared. Tan theta squared plus 1 is what? Sec square theta. So I'll put it there straight. Okay, if you don't understand this, I have a video on this, you can just check it up and watch it, okay? So tan square theta plus 1 will give me sec square theta, then times dt is what? There is a dt, there's supposed to be a dt here, okay? Dt is what? That's what I wrote it somewhere here. So dt is actually equal to 2 sec square theta d theta, okay? So this will cancel this, and the 2 will take this 4 and we'll get 2, okay? So we actually have integral of half d theta, okay? And if you remember our basic definition in integration, we said something that if you have a constant you're integrating, it's just a constant times the variable that you're integrating with respect to. Okay, so now this integral has turned to integral of half the theta, which is equal to half theta plus c. Okay, so from this side t is equal to 2 tan theta. From this side, rather, this side. Okay, what will be our theta? So from this side, theta is equal to what? Or let's say from this side, theta is equal to tan inverse of t over 2. Okay, so we get the whole of this integral that we are solving. We are just writing the final answer. Half tan inverse of what? T on 2. Okay, plus c. But this original t from this side, okay, is what? Tan x over 2. So it means the main integral question is half tan inverse of tan of x over 2 plus c. This is the final answer to this question. Okay, so that is it. And if in case you don't understand anything, just comment on the comment section below and I'll do a video to explain your comments for you. Okay, thank you and see you next time.